Hello. This is a video about 9.2 similar polygons. We won't answer every question in this video, but I hope this video will give you an idea of how to answer questions like these and how to do the homework. So first question, in a triangle, we have some triangle. The measures of the sides, the ratio of the measures of the sides is 4 to 6 to 9. So let's just assume the sides are 4, 6, and 9. Notice this is a valid triangle because 4 plus 6 is greater than 9. If you were to double each side length, what would the perimeter equal? Currently, the perimeter for this one is 19. To find the perimeter, we just add the side length each side of the triangle. If we were to double the side lengths, if we were to double each side length, we're going to have a much bigger triangle. And if we double each side length and then find the perimeter by adding 8, 12, and 18, that would be 38. The thing to notice here is the perimeter doubles. If we were to triple each side length, what would the perimeter equal? Well, it would be 3 times the original. Suppose we dilate the triangle by a certain scale factor and got a perimeter of 209. This is working backwards. Initially we had a perimeter of 19. Now the perimeter is 209. 209 divided by 19 is 11. So each side length, 4, 6, and 9, are going to be multiplied by 11. So the side lengths would be 44, 66, and 99. Is this polygon a dilation of this other polygon? To be a dilation, the corresponding angles have to be congruent, and these corresponding angles are congruent. These corresponding angles are congruent. These corresponding angles are congruent. And these corresponding angles are congruent. Also, to be a dilation, you have to have the same scale factor, which is the amount that we've multiplied to make the shape bigger or smaller. So the scale factor can be found by dividing 7.5 by 3. So that's the amount that was multiplied to make this smaller triangle into this bigger triangle. Are the following triangles similar? To be similar to what I said about dilations above, the corresponding angles have to be congruent, which they are, and you have to have the same scale factor from one side to the next. So in this diagram, these angles are congruent, so that's good. These angles are congruent. These angles are congruent, and these angles are congruent. So that's halfway there. Lastly, we have to make sure that it's the same scale ratio. So let's go from the angle marked with 1 congruent sign to the angle marked with 2 congruent signs, just to make sure we're matching the angles correctly. So that would be 20 is a corresponding side of 12. Does that equal 15 over 9? And does that equal 24 over 14.4? And does that equal 25 over 15? I don't have a calculator handy, but I could do a few of them. If I, let's see, divide by 4, that would be 5/3. If I divide by 3, that would be 5/3. I don't know what this one is. If I divide by 5, that would be 5/3. So if you could check that this gives you 5/3, then we'd say, yes, they're similar polygons. But sadly, I don't know. If they are similar, the similarity statement would identify J, K, L, M would be similar to, we use just a little tilde, a little wavy line there. And then we'd match the angles. J matches with Q because they're congruent. And then we went R, S, P. So that's only if this answer is 5/3. So you can check that. If it's not 5/3, then we would not have a similarity statement, and they're not similar. But if it is 5/3, then this is our similarity statement. I'd encourage you to pause the video and read about similar polygons. We've talked about it, but here is it written out if you need things written out. And then read about the scale factor. And then read about the similarity statement and see how the angles are congruent and the corresponding sides are proportional. Proportional means that each of these ratios of the corresponding sides are equal. After you've read that, we'll look at our next page. And if you read that, you might be able to fill in the blanks here. So go ahead and pause the video and see if you could fill in the blanks, and then ask your neighbor what they put in these different spots. So if you're asked, determine that the pair of figures is similar, then show all the corresponding angles are congruent. And show all the corresponding sides not congruent here, but proportional. So corresponding angles of similar polygons, congruent. Corresponding sides of similar polygons are proportional, meaning you have these fractions are equal to each other. So for each of these questions, you're going to do something like this. First, you need to make sure that the corresponding angles are congruent. These are both 90, that's good. These are both 30, that's good. And as a triangle, the angles add up to 180, so these two angles should be 60, so that's good. So angle A is congruent to angle D. Angle B is congruent to angle E. Angle C is congruent to angle F. So that's the first thing. That's usually the easiest thing to determine. Step 2, we have to find that the ratio of the sides are proportional. So I'd start with the 30, go to the 60. So that would be 12 over 9. That needs to be equal to 6 over 4.5. And that needs to be equal to 6 root 3 over 4.5 root 3. I don't have a calculator, but you can determine, do each of these equal each other? If they do, then we would say they're similar triangles. But that's only if they equal. The similarity statement, if they are similar, would be ABC is similar to DEF. Make sure you get the order correct. where A and C, A and D are both 30, B and E are both 60, C and F are both 90. That's only if these are equal. So you can pause the video and get your calculators out if they're not out and see, are each of those equal to each other. You can check the notes in the answer key for these two. Or you could pause the video. That might be a good idea. Pause the video and try those, and then compare your answer with your neighbor. On this question, you're told that the two polygons are similar, and we can use that fact to write the similarity statement. Just make sure when you're writing the similarity statement, you're matching angle A and angle R in the same position in the similarity statement. The similarity statement will be a bunch of letters similar to a bunch of other letters in the other polygon. The scale factor, we just need to find a side in this polygon that you know the length, which is 6. And the corresponding side would be 4. So the scale factor would be 6 to 4. You could also state, instead of going from this triangle to this triangle, if you went in the other direction, you could also say the scale factor is 4 to 6. So be careful of how you're comparing these. To find the value of x, I'll use my 6 over 4 going this direction. So if I'd like to find the value of x, that just means I need to put x in the numerator. And that corresponds with 3. If you use the 4 over 6, it would look like this. 4 over 6 equals 3 over x, because then we would be going from this triangle to this triangle. So be careful about that. And in the first lesson, in your homework prior to this lesson, you solved proportions like this. So if you don't remember how to solve that, go back in your notes and look it up. I'll let you answer D. If you pause the video, you can answer D and compare with your neighbors. I'll also let you answer this last question. I'd encourage you to draw the triangles and label the triangles, and then it becomes similar to one of these types of questions. Thanks for watching this video. I hope that was helpful, and I hope to see you soon.